Hi, this is probably my last video on how to analyze your laboratory data. So here we go. This is talking about the protein concentration measurements that were made to finish your protein purification table. So the first thing you have to do is plot a Bradford standard curve with the top data in this table. So Bradford standard curve, we have a different standard protein with a different concentration. So you'll have to take that into account. And we did it in duplicate for 6 different samples. The duplicate absorbance measurements are here, so you'll have to average those. And those will be your Y values that you plot. And then your X values will be the micrograms of protein. Notice this column is empty, and I left that empty so that you could calculate those. Here are the volumes that you used of that standard protein, and here's the concentration. So in order to calculate these in micrograms, you would take the volume that you used, so we'll do the first one, 4 microliters, and times it by the concentration of the standard protein, which is 1.46 milligrams per mils. So that will equal 1460 micrograms per 1,000 microliters. So I just times both of these units by 1,000, so that equals 1460 micrograms in 1,000 microliters. So just put that into your equation. Microliters will cancel out, and that will equal 5.84 micrograms. So those values then go in this column, so we'll put 5.84, and then you can figure out the rest of them. So those are your X values. The average absorbance is your Y value, and then you would make a standard curve plot like you've done before. 595 on the Y, micrograms of protein on the X. You'll get a positive slope. Write down the Y equals mx plus b equation, or do linear trend line, and also get your R squared value. So this plot goes only in your notebook. You do not need to put this plot in your report. You will use this equation to solve for the concentrations of your experimental samples, and you'll need the R squared value to comment on in your report if your standard curve was a good plot or not. But you don't need the plot anywhere but your notebook. All right, let's go back to the data. So here we have the crude, the redissolved pellet or dialyzed protein sample, and we have the Cephedex fraction. So we measured those values on those samples in terms of Bradford assay, and we did them in duplicate again. So here are duplicate values, so you'll have to average those. They were all done at 60 microliters, so no water. Once you get these average values, you will put them into the standard curve equation for Y, because they're absorbances, and you will solve for X. X will be micrograms if you do the X axis in micrograms, and then you will divide by 60 microliters for all of them, because they were all 60. And then that will be equal, whatever you get will be equal to milligrams per mil. And that concentration you put in your purification table for each of those 3 samples. So if you remember that table from the first week of the lab, these values should be done already. Here's your measured volumes. And then for the final one that you should have calculated at the end of this week, it's 2.0 for the volume. So it's just the volume in that particular test tube. It's not the VO or the volume to get to that test tube. It's just the volume of that test tube. So this should be 2. Okay, so the milligrams per mil that you calculated here for the crude, the pellet, and the Cephedex fraction goes here. And then you will take this total volume and times it by this to get this, just like you did over here. the total volume, gets rid of the milliliters in this column, and you'll get total milligrams. So just for an example, let's say our concentration of protein was about 0.5. 27 times 0.5 is, I think, 14.5. Let's just do that. 27 times 0.5, 13.5. So 27 times 0.5 is 13.5. And let's say our redissolved pellet was about 1.5. So then 1.5 times 4 would be 6.0 here. And then specific activity, you take the total units, which is the number here, and you divide it by the total protein. And based on this was about 14, if I remember right. 14 divided by 13.5, we're going to get about 1.04 here. So taking this and dividing it by this, because it's unit divided by milligram, we get that. For this one, it would be total activity here, which was about 9. So we'll say 9 divided by 6. That's going to be 1.5. So this is approximately 9. This is approximately 14. That's how I got those numbers. You can complete this one based on what you got here. But the last thing I want to show you is how to do this part. So purification fold is this number divided by this number. Or in the case of the first row, it's this number divided by itself. That's why you get 1. So to get this box, we take 1.5 and we divide it by 1.04, which is roughly going to be 1.5 or 1.44. So that's the purification fold. Then when you get this number, whatever this is, you divide it by this number and write that number in here. Then if your purification was successful, these numbers should increase. So 1 to 1.44 is better or good. And if this number is larger than 1.44, then your purification was successful. So if you have any questions over this, don't hesitate to get hold of me. But I think this wraps up the data analysis for this lab. And then next week, when you turn in your notebook sheets, this all should be complete. All the boxes should have numbers in them.